Let's see here. Let's go ahead and start up on equations of variables on both sides. How many have done problems like these? Okay, so why don't you tell your neighbor what you do on number 3, what you think you should do to solve that one there. And zoom in there. Go and zoom in number 3 and 4. All right, JC, what do you think? What are your plans for this one? Give me your best guess. Maria, you want to help out? No thoughts? All right, back row. You guys come up with a plan of attack. Come on. Kinsey, what's up? No, don't tell. Jeez. How many have a plan? Okay, what's our normal plan? Like if we were to do this problem, what's the first thing we should always try to do with an equation? What's our, I guess not the first thing, what's our ultimate goal with an equation? Go for it. Variable. Okay, find the variable. All right, so get the variable alone on the side. All right, so right now the problem I have is I have variables on both sides, right? So if I want to get the variable alone on one side, then it's probably a good idea to collect all the variables on a single side. So if you didn't know that, that's something to add to your notes. My goal is to collect all variables on the same side. You've got to get all the variables on the same side. So if I have 7 C's here and I have 9 C's here, let's move them all to one side. I always like to move the smaller amount to the other side. So I'm going to bring these 7 C's over to this side by subtracting them. Now I subtracted because that's a positive 7C. And it gives me 7C minus 7C is? That's 0. What am I left with over here? Cole, what do you got? Negative 4 on this side. All right. Okay. So Maria, what am I left with on this side? Yeah, I got a negative 11. What else do I have? 2C or not 2C? That isn't a question. Okay. You guys should have seen the shirt I got this weekend. It is pretty cool. It won't make much sense to you right now, but later in the year it will. I'll show you later. It's pretty cool. All right. Go ahead and tell your neighbor what the next step is. All right, Jane Jens, what do you think? Add 11 to each side. Now, just out of curiosity, did anyone add the 11 before they moved the C's? So that's what, and that's okay. You could have moved the 11 first and then moved the C's. I always move the variables first, but okay. When I add 11, what am I left with on this side, Ayla? 11 positives, 4 negatives. What's that? 15? If I have 4 negatives and 11 positives, do I have more positives or negatives? Positives. How many more positives? I have 11, but how many more than negatives do I have? 7 more. So our answer is positive 7s. Okay, and over here I have, Josh? 2C. Or not 2C. Once again, not a question. All right, so divide by 2, 1C is? Yeah, some of us say 3.5. I just like to say 7/2. Leave it as a fraction. If you really need to go through that extra step and divide the 2, you can, but that's the fraction, 7/2. Dude, here we go. Any questions on it? How many of you wonder when you get a fraction if you did it right? You're like, oh, I'm not sure if I should get a fraction. Yeah. Okay, well, let's just real quick check. If I go 7 times and I put 7/2 in for C, minus 4, and I go 9 times and I put 7/2 in for C, minus 11. Now some of you go, that's pretty tough, man. But I get 49/2 right there for this part. So that's 49/2. Notice I did 7 times 7 divided by 2 minus 4. So I'm going to write that down here. 49/2 minus 4. And what do I get here? Brennan?
63 over 2.
63 over 2. Someone explain to me how he got 63 over 2, please. Patrick, you got it?
He multiplies the 9 by the numerator and then divides by the denominator.
Good. 9 times 7 divided by 2. So 63 halves divided by 2. 63, not 62. All right. The question is, does this equal that? They don't look the same. What's half of 49? What's half of 50? 25. So what's half of 49? What? 24.5. 24.5 minus 4 is? Everyone? 20.5? That's not everyone. 63 cut in half. What's 60 cut in half? 30. What's 3 cut in half? 1.5. So what is it? 31.5. Minus 11. Well, subtract 10 first. What do you get? 21.5. And then minus another 1. Hey, dude, they're equal. That's right, man. Okay, always could check your work. All right, any questions there? All right, I want you guys to give this one a go. Number 4, on your own.
I added 4 on each side, and I got 3 equals 10d plus minus 17. And then I added 17 on each side, and I got 20 equals 10d, and then I divided by 10 on each side.
Wow. How many got 2? You did 2. Hey, very good. Can I make one comment here? I think Mackenzie did a really good job. One step, and I'm wondering how many of you did this. How many of you left the D off this right here? I see it every year. I'm just curious. So as you progress in math, not that that's a major issue other than because it's just your work, but as you progress, your problems become longer and longer. If you forget little variables like that, what could end up happening is if you go back and check your work later, you may forget that you left the D off and you're confused. But yeah, that's for sure right. D equals 2. Well done. Woohoo! All right. I think we're going to skip that one. Any questions on it? Rate yourself 1 to 5. 5, you got it when you're struggling? Okay, 2 special cases. 2 special cases that I want you to see. So as you go through these 2 problems, you're going to be going, huh, that's kind of interesting. Well, maybe you'll say that. There's number 6. Go ahead and work that one out. Hey guys, we're about done with equations, so just so you know, look, remember we talked about this a bit last week. The reason you draw your line is to separate expressions. So you now have 2 expressions. You have this, 6m minus 5. Can I put any of that together? Can I put those 2 things together? How come? Annalie? Very good. They're not like terms. There's a variable on one, not on the other. Okay? And then you have this expression, 7m plus 7 minus 7. Can I put anything together on that side? Jaden Kinchin, what you think? Yeah. Which ones? The m's. I have m's and I have an m's. I have m and m's. Those are pretty good. Those are fit to eat. Did you see that picture by the coaches? Go online and look at your email. Not very nice. Bunch of chumps. Anyway, we got m and m's. 7 m's and 1 m. Well, that's a negative m. This minus goes with it. I have 7 and negative m. What do I have? 6m. Someone ate an m. Dude. Okay, 6m plus 7. Okay, we've simplified this side. That equals 6m minus 5. Now, some of you see the problem right away. Okay? But the whole, just to back up, the whole reason we went through combining like terms is so that when we get to a problem like this, we can simplify each side first. Okay? The reason we do distributive properties is so when we do this problem later, we can simplify each side first. Okay? That's the point of those skills. All right, so when we look at this, if I have 6 of something and I subtract 5, can that equal 6 of that same something plus 7? If I have, everyone think of something in your head right now. Everyone have it? Okay, think of 6 of them now. All right? So you're like, all right. All right, and I subtract 5 whatever's from it, $5 from it. And it may not make sense in your picture. Okay? So I have 6 little doggies. Okay, and I'm subtracting 5. Okay, you guys with me?
Yeah.
Okay. Here, I have 6 of something, and I'm adding 7 to it. Can that be the case? Can these two things coexist? Are they equal? They can't be the same. And if you don't recognize that, well, what's the next step? Minus 6. If I take away 6 m's on both sides, what happens? Yeah, you get 0m here, which is just 0, so that's gone. I'm left with what? Negative 5 equals, that's 0m equals? 7. When does negative 5 equal 7? Negative, that's like owing $5, meaning you have $7. When is that the truth? That'd be great, dude. Hey, you owe me 5. Whoa, that means I have $7. All right, score. Okay, is that ever true? No, this is never true. Okay, they're not equal, which means in math, that's a no solution. Hi.
I think we just. Oh.
Keegan,
I got 0 equals negative 2.
is that true?
Yeah. No.
No. That's also no solution. Anytime your variables disappear and you're left with a false statement, then that means no solution in math. So both your variables, all your variables disappeared and you're left with a false statement. That's no solution. Any other questions on that one? Okay. Once you start, go ahead and simplify this one there. Okay? Okay, can I put 10 and 8 together? Nope.
No.
Can I put those two? Ooh, look at my blink. Okay, can I put those things together?
Yes.
Yeah, what do I do?
Uh,
Distribute. So I have 2 5s, which is 10, and I have 2 negative 4 A's, which is negative 8A. Okay, so I have 10 minus 8A equals 10 minus 8A. Is that true? Yeah. And in fact, if you combine like terms, if I add these 8 over here and add them over here, well, now I have negative 8A plus 8A, which is 0. So I'm left with 10. And I have negative 8A plus 8A is 0, and I'm left with 10. Does 10 ever equal 10? Yeah, it always equals 10. I mean, if I say I have 10 of something, that means I have 10 of those somethings. Okay? All right. So 10 equals 10. That's always true, but the variables disappeared. Well, if the variables disappear and you get a true statement, in math, that means infinitely many. Many solutions. Okay? It's also known as an identity. Now, you won't hear that term as much anymore. Sometimes you might hear it. Infinitely many solutions, also known as an identity. Okay? You've been given 2 special cases now. A no solution and an infinitely many. Okay? There are similarities about both of those. All right? What's similar about each of them? Tell your neighbor what's similar about each of those. Okay? Jennifer, what do you think? They are both equations. We start with equations. What do they both? What happens in both of them? What do you think? You don't know? What happened at the end? What isn't there? Yeah, the variable disappeared in both of them. The variable's gone. Okay? When the variable disappears and the statement's false, it's a no solution. When the variable disappears and the statement's true, it's an infinitely many. You should add that to your notes if you didn't already know that. Okay? Remember, infinitely many is also called an identities. Okay, any questions there? All right, I want you guys to take the sheet. Okay, so on the worksheet you're getting there, we're going to look at number 16. It's from example 3. I want you to show your work in your notes. You don't have to copy down the problem, but put this work in your notes because it's talking about a formula. Distance equals rate times time. All right? So go ahead and read through the problem. Get it started up in your notes. I hope you guys read through it. These problems are they can be a bit confusing. They can kind of twist your mind. Remember, it's about reading through and then focusing in on that last sentence. Why do we always focus in there? It's been kind of a common theme. I keep asking the same question every lesson. Yeah, Caden?
Because it gives us what kind of like multiplication and addition.
It doesn't necessarily give us that. It does tell us something, though. Trinity? It tells you what you're looking for. It tells us our variable, usually. How long does it take each train to make the trip? Okay, well when they say how long, they're usually talking about time. Okay, so I'm going to define my variable, t as in time. Now, we don't know necessarily what time yet, like what we're measuring it in. I mean, time could mean minutes, it can mean seconds, it can mean hours. Okay, it just depends on the context of the rest of the problem. And the rest of the problem, what are we measuring in?
Hours.
Yeah, hours. How do you know it's hours? Dude.
Because it says 60 mi/h, which stands for miles per hour.
Good. So I'm not going to assume anything. This means mi, miles, per, and that's hour. Okay? So this is time in hours. All right? So I'm going to use a formula here called distance equals rate times time. Okay, so how many have heard that formula before? You guys didn't use that in 8th grade? Okay. Well, let's define it then. Make sure that we're clear on it. It's one you use a lot. Distance. It's hard for me to write downward like that. Let me try that again. Distance equals rate. What's a rate? Go ahead.
The amount something goes by.
Okay, the amount something goes up by. How many have ever traveled in a car? They're these things with 4 wheels, most of them. Okay, they go kind of fast. How many have well, I don't want to know the fastest. How fast do you travel on the freeway usually? About. Yeah? 65, that's speeding, dude. It's supposed to be 60. Okay. Well, let's go with 60. Can we go with 60? You go 65. How many go 65? How many are going 70? How many are going 80? Don't be doing that. Don't tell me what your parents do. I don't want to know. All right, so let's go with 60. I want to be traveling speed limit. Okay, our rate is 60 miles an hour. Now, let's say I have to, let's just forget about the problem for a minute. Let's say I have to go 120 miles. Okay, at 60 miles an hour. How many hours is it going to take me? On your fingers, show me. How many hours? That's not good. Okay, let's try this one. If I'm going 60 miles per hour, that means 60 miles in 1 hour. How many hours will it take me to go 60 miles? Everyone on your finger. Yes, very good. Now, some of you had to look around and confirm with your neighbors that you were right. It's okay to take the guess. I mean, it's not like you're going to get in trouble, okay? Let's say you're going 120 miles. By the way, how many 60s is that? 2. How many hours is it going to take you to go 120 miles? That's 60 miles an hour. 2. Okay, let's say you're going 300 miles. Big jump here. 300 miles at 60 miles per hour. And your dad is like, dude, we're not stopping until we're there. You're like, are you kidding me? That means I have to wait how long to go to the bathroom? Yeah, 5 hours. Now, anyone have a dad like that? Dude, it's like a competition. You got to make your best time. We don't stop. We go 15 hours in my car. No, I'm joking. We don't do that. That'd be mean, man. Sheesh. We have a porta potty pull up right beside the car. The kids pop. No, I'm joking. That doesn't happen. All right. Distance equals rate times time. All right. You guys use this formula all the time. You just don't know you use it. All right. So your distance, in this case, a passenger train travels 60 miles per hour and the freight train travels 40 miles per hour. So they're telling us what? Is that a distance, a rate, or a time? Yeah?
Rate.
This is our rate. This is a rate. and this is a rate. Well, we have two rates. Well, yeah, because you want to know when will the passenger train equal the freight train. When are they going to go the same distance? Passenger distance equals the freight train distance. Okay, they're going the same travel. The passenger train travels 60 miles an hour and the freight train travels 40 miles an hour. It takes the passenger train 1.5 hours less to cover the same distance. That's a key piece. That means this distance equals that distance, which means this, remember, another way of saying distance is rate times time. That means the passenger's rate times time has to be equal to the freight train's rate times time. Now, usually in math, when we show something like this, and how many are taking Spanish this year? Okay, I really think math can be a foreign language that you have to learn. Okay, like passenger rate times time, the way we write this when we have two of the same thing, when I say the rate here, that's the rate of the passenger. When I say the rate here, that's the rate of the freight train. They're two different rates. When I say the time here, that's the time of the passenger. And when I say the time here, that's the time of the freight train. Everyone with me so far? Do we know the rate of the passenger? Yeah, what is it? What is it? 60, nice. Okay. Do we know the rate of the freight train? Yeah, it's 40. Okay. We are now done with this top sentence. Dude, we are eliminating the words as we go. Okay. It takes the passenger trains 1.5 hours less time to cover the same distance as the freight train. So if we said time and H, we have to define which time we're dealing. Is this going to be the passenger train's time or the freight train's time? Which takes longer? Yeah. It takes the freight train longer. They're traveling slower, right? So if I say, well, this T is going to be the freight train's time. Okay, so time of freight train. If that's going to be the freight train's time, in relation to the freight train's time, let's call the passenger's train, rather than saying that's the passenger's train time, let's say, well, if I take the freight train's time, what do I have to do to that to make it equal the passenger's train time? Yeah.
Subtract 1.5.
Yeah, I have to subtract 1.5 hours because he goes a little faster. Have you ever driven in your car and your friends took off at the same time and you guys were going the same place and they got there first? Or you got there first? Does that ever happen? Yeah? Maybe you're driving and you're cruising along and all of a sudden I don't know, you're on the freeway and you pass your friend, you're like, hey dude, that's my friend, they just got pulled over. What's up with that? Dude, you get there first. I mean, that could happen. Right? That means your rate's a little faster. Okay? So let's go ahead and distribute that. We've now got our formula set up here. Okay? 60t minus 60 times 1.5. Well, don't use your calculator, use your brain. What's 160? 60. What's half of 60? 30. What's 60 and 30? 90. Dude, we used our brain. I know it hurt, but we're okay. There we go. And we solve it up, right? I'll let you guys finish up that piece. Josh, you got it? Maybe. If I subtract 40t, if I follow the rules kind of that I was doing earlier, notice when I do that, I just moved everything to the same side. Did anyone do that? Now be careful. Don't start moving your variable around just because you're like, oh, hold on, I got to put this over here and this over here. I just moved everything away from this side, which means what's my next step? Yeah, I better move my 90 back over. Did anyone just move the 60 over instead? It probably would have been the wiser choice on my part, but I'm just trying to show what are some of the mistakes that I see. Some students get to there and they're just like, well, I get a negative answer, Mr. McCoy, because I divide 90 by 20 and it's negative, and that's not true. You got to move that 90 first. So 20t equals 90. Divide by 20, you get 1t is 9 halves. Well, what's 9 halves of an hour? What's 9 divided by 2? 4.5. 4.5 hours. Well, that's, yeah.
Why would it be wrong to move the 60 and subtract the 40?
You can. You could have moved the 60. That's okay.
But you would have gotten a negative.
No, because then you have a negative divided by negative. You should have a negative 20 over here. Yeah. Hey, so what time did we just find out? Whose time? Yeah, remember our variable. T stands for the time of the freight train. So the freight train took 4.5. Did we answer the question? We get half credit. Everyone tell your neighbor what the other part of the answer is. All right, hopefully we had passenger train equals how far or how fast?
Oh, you just add 1.5.
Go ahead.
You just add 1.5 hours to it.
Do I add 1.5 to it or subtract it?
Oh,
Yeah, subtract, right? The passenger's going a little faster, so subtract 1.5, we get? 3 without our calculator, man. 3 hours. All right. Okay, there we go. Kind of a tougher problem. Your assignment today